We're going to get into the basics of machine learning, which basically means we're going to conceptually develop a foundation of machine learning. Then we'll transition more into an application of it with Python. So a few important quotes here when we get into this. So Arthur Samuel said that the field of study that gives computers the ability to learn without being explicitly programmed. So these are references to what is machine learning. And then there's Tom Mitchell. A computer program is said to learn from experience, which he calls it E, with respect to some class of task, T, and performance measure, P. If its performance at task in T, as measured by P, improves with experience E. So what does all that really mean? He kind of puts this into maybe some terms that we're not really sure what exactly is going on. So here's kind of the translation of that. Let's take an example of playing checkers. So you have E, which is the experience of playing many games of checkers. Now the task is playing checkers, and then P is the probability that the program will win the next game. So that's basically Tom Mitchell's translation into something a little more concrete and applicable. Now there are three areas we're going to look at, which is supervised learning, unsupervised learning, and then we have something called semi-supervised learning. And basically in general, any machine learning can be assigned to two broad categories, which are really supervised and unsupervised. So this is reinforced learning and recommender system is what they're called. Then we have this third component, semi-supervised. So when we talk about semi-supervised, we have a learning algorithm which takes help from both supervised as well as from unsupervised. So let's look at a graphic of the relations of these and then the subcomponents of them as well. So just kind of to summarize here of what's important, supervised and unsupervised are really the main categories of machine learning, and then you have semi-supervised kind of taking from both of these. All right, so here's our graphic. At the top we have machine learning. Then we divide it up into these different components. We have our supervised. Within it, there's two areas, classification and regression. And then we have our other major component, which is unsupervised learning. It has something called clustering. We're going to get into the details of what each of these are. So let's start with supervised learning. We have regression. So it's one of the components. We have regression and classification. So with regression, we basically have a regression problem, and we are trying to predict the results within a continuous output. So that is key for regression. So thinking about this, we have that we are trying to map input variables to some continuous function. So continuous is really the main theme here when we talk about regression. As well, predicting a value is regression. So housing prices, my age, the temperature, these are all related to a regression problem. We're trying to predict results within a continuous output. And if we look at the algorithm that is used to implement regression, it's called linear regression. So let's move into some examples. Here we have a graph with cells and then predicted cells. This may be, for example, home prices. So given data about the size of a house on the real estate market, we can try to predict the price. So price as a function of size is a continuous output. So this is basically a regression problem. Now, another problem might be, for example, a picture of a person, and we have to predict their age on the basis of the given picture. That again, regression. All right, let's talk a little bit about what classification is. So in classification problems, we're trying to predict results in a discrete output. So that's a main difference against regression, which is continuous. In other words, we're trying to map input variables into discrete categories. And the algorithm used to implement classification is called logistic regression versus linear regression. Predicting a class is classification. So we have, let's say, not spam or spam, and another may be cat or dog. So very discrete values there. All right, so we're going to look at an example now. So with this image, the above image shows that the values can only be a chair or a table. There's no in between, which would be continuous. in the case of this particular classification. So kind of getting into some other examples, we could turn regression example into a classification problem by making our output about whether, let's say, a house sells for more or less than the asking price. And in this case, we're classifying the house based on price into two discrete categories, which are yes or no. And then let's say we're given a student subject and they have grades. So we have to predict whether the student is passing or failing. Now, there can be a range of grades, of course, that are pass, and there can also be a range of grades that are fail. But ultimately, if you're looking for pass or fail, those are discrete, they're binary, you have to choose one. Now, another one would be spam folder and email. That would be an example of a supervised learning. Okay, so let's move into unsupervised learning. So here we have unsupervised learning allows us to approach problems with little or no idea what our results should look like. We can derive structure, though, from data where we don't necessarily know the effect of the variables. We're getting now into an area where we want to know what is the pattern. Give us some idea from all this data because we don't really have an idea. And then we can derive the structure by clustering. It's a key component. The data based on relationships among variables in the data. So the machine learning algorithms would do that for you. It would create the clustering. Then you start seeing some patterns. You start getting a better idea of the relationships that are going on with the variables in that data. So just kind of expanding on unsupervised learning, let's say we don't even know what is wrong or what is right. We just really have no idea of what's going on. So the algorithms will divide up the problem into those clusters or parts. We really just don't have any prior knowledge of the data like we had with supervised learning. So we have to derive everything from our newly given data set. So some examples of unsupervised learning would be market segmentation. So before launching a product, we divide the market into specific categories and choose a category to target. Or a social network analysis. In this case, we would think about how people use the social network, how people maybe connect with each other. So another way to basically explain unsupervised learning is setting where you give the algorithm a ton of data and just ask it to find structure in that data. So unsupervised learning problems can be further grouped into clustering and association problems. So with clustering, it's a problem where you want to discover the inherent groupings of the data, such as grouping customers by purchasing behavior. And then we have association, which is a rule learning problem where you want to discover rules that describe large portions of your data, such as people that buy X also tend to buy Y. And then we have a few examples here. So K-means is a clustering problem. We have a priority algorithm for association rule learning problems. So we're going to see more of those. Okay, so what we're going to do next is get into some examples with clustering, and we're also going to look at semi-supervised.